Today will be our second day working with multiplication and division problems, but there's going to be a bit of weirdness today. Number 29 looks normal enough. We will divide both sides by 7 to get -2 is less than or equal to x. And as far as graphing goes, we're going to flip the whole thing around so that our variable's first. X is greater than or equal to -2. So we're going to put a circle at -2. We're going to fill it in. We're going to put an arrow to the right. Nothing at all new there. Now, something I do want to point out is we can actually check to make sure that we're right by picking a number that fits that description of being bigger than or equal to -2 and making sure that it does, in fact, work. So a number that's bigger than -2, 0, nice and easy. So the question is, would -14 is less than or equal to 7 times 0 be true? Well, 7 times 0 is 0, and -14 less than or equal to 0? Yes, it's less than. Now there's going to be some weirdness showing up. You can copy as I solve this problem, but after I have my statement that n is whatever relationship to the number, don't copy for a little bit. Let me explain something that happens that's a little strange here. Actually, now I think about it, just don't copy anything for a moment. Just don't copy anything, just watch. So it's like, okay, we got to take that -8 off the end. No big deal. We can divide both these sides by -8, and that gets me a -9 is less than n. And when I reverse that, I get n is greater than -9. So far, so good. We can graph that, no problem. But let's check it. So a number that's greater than -9. And again, on this number line, if you look at it, you might think you have to pick -8, -7, -6, something that's on this number line. But truly, any number greater than -9 is fine. And one of my favorite numbers to work with when checking, if I'm allowed to use it, is 0. And 0 is absolutely greater than -9. So let's check 0. So 72 is less than -8 times 0. According to what we have here, 0 should work. So 72 is 72. -8 times 0 is 0, and this tells me that 72 is less than 0. I think you would all agree with me that isn't true. So things greater than -9 definitely don't work here. Even if you got as close as you could and went to -8, -8 times -8 is +64, and 72 is not less than 64. Let's try something that doesn't look like it should work. Like -10. It's on the wrong side of the circle, according to what we have here. So 72 is less than -8, and we're checking to see if -10 works. Well, -8 times -10 is +80, and 72 is less than 80. So what's going on here? Why did this give us the wrong answer? What did we do wrong? Technically, nothing. There's a rule that I didn't mention, specifically so you could see what happens if you don't do it correctly. And that rule comes in at this step, after we do the divide by -8. So you can copy to this point now. Here's the rule. If you multiply or divide by a negative number, flip the inequality symbol. I divided both sides of this by -8. So I'm going to flip the inequality symbol from less than to greater than. Now when I graph this, I'm going to flip the entire last statement. So I'm not undoing what I just did. I'm just rewriting it so that I can see, okay, n is less than -9, circle at -9, arrow to the left. We already know this is true because we checked -10 and -10 worked. So here's your new rule. If you multiply or divide by a negative number, flip the inequality symbol. You'll notice we didn't do this at all yesterday. I didn't do it on number 29. And those are all correct, by the way. All 6 problems from yesterday, number 29, absolutely fine. And some of them involve negative numbers. We only have to worry about this whole do we, don't we, if the number with the variable is negative. And specifically, if it's attached by multiplication or division. So again, this rule does not apply to addition. It does not apply to subtraction. This is strictly when multiplying or dividing. So now let's do a couple of problems where we now know this in advance. Number 31, -2p is greater than or equal to -4. I'm going to divide both sides by -2. Because I am dividing both sides by a negative number, not because the 4 is negative, because the 2 that I'm dividing by is negative, I am going to flip that inequality symbol the other way. Outside of that, I do the math normally. -4 divided by -2 is +2. P is less than or equal to 2 is the correct solution. We're going to put a circle at 2. We're going to fill it in. We're going to put an arrow to the left. And again, you can check this very easily. Pick a number there, like 0. -2 times 0 is 0. And is 0 greater than or equal to -4? Yes. And number 32, we'll need to divide both sides by -7. That'll get us x. That'll get us 10. Negative divided by a negative is positive. But we did divide both sides by a negative number. So I have to flip that inequality symbol. Again, it's not because the 70 is negative. It's because the 7 that I'm dividing by is negative. Less than or equal to 10 is a filled-in circle at 10 with an arrow to its left. I invite you to pause and try 33 and 34. Because we're dividing both sides by a negative number, we are going to flip the inequality symbol. A negative divided by a negative will be a positive. Now, how do I figure this out? You can do long division. I'm going to verbally explain my reasoning. 18 times 2 is 36, so 18 times 20 is 360. The number we're looking at, 342, is 18 less than 360. So that means I'm not multiplying the 18 by 20 to make that. I would multiply it by 19. X is greater than or equal to 19. Filled in circle at 19, arrow to the right. And finally for today, number 34, we're going to have to divide both sides by -14. Because we're dividing by a negative number, we are going to flip the inequality symbol. -70 divided by -14 is +5. We flip the inequality symbol to a greater than. We write our x. Before we graph, we spin that entire statement around so that x is first, just so I make sure I'm reading this properly. X is less than 5. Open circle at 5, arrow to your left.